Hello everyone, welcome back to Native Engineering once again. The exercise that I have reads as follows. The coupling shown in figure 1.24 is subjected to a tensile load of 100 kilonewtons. And then they gave us the diagram below, which is figure 1.24. Then they give us the calculations. They say, calculate the diameter of the coupling rod D if the allowable tensile stress is 100 megapascal. Question number 2. Calculate the shear stress in the coupling pin. Question number 3. They say calculate the tensile stress in the fork of the coupling. So this is the information that we are given. This is the diagram that we are given. They're giving us the load that is applied here. It's 100 kilonewtons, and this is the fork. They're giving this thickness of the forks as 15. They're giving us the diameter of the pin as 20 millimeters, and then they are giving us the diameter, this diameter of this semicircle from here to here. The diameter of the semicircle basically as 80 millimeters. And then they are asking us to calculate, question number 1, the diameter of the coupling rod. The diameter of the coupling rod D, if the allowable tensile stress is 100 megapascal. D, this is the D that they are talking about. So we are going to say, since we are given the tensile stress, we know tensile stress is given by force divided by area. The force we have, and the area we have, the stress we have rather, we are looking for the area. The area, that is where we are going to get our diameter. So what we are going to do is we are going to make the area the subject of the formula and say 100 times 10 to the power 3, which is our force, divided by our stress, which is also 100 times 10 to the power 6 for the stress. And doing this, I got our stress as 1 times 10 to the power negative 3. So now we have our area. From the area, we are going to get the diameter. We know area is given by pi divided by 4 times d squared, and this is equals to 1 times 10 to the power negative 3. And we say our area from here, it's going to be, from here we are going to make d the subject of the formula, which we are going to get as d squared. It's equals to 1 times 10 to the power negative 3 times 4 divided by pi. And we're going to have to remove this square root. This square, we are going to introduce the square root, which will cancel out with this one. And we get our diameter for the rod is 0.03568 meters. And then remove this, which can be expressed in millimeters as 35.68 millimeters, and that is what they are looking for. We go to the second question. They say calculate the shear stress in the coupling pin. The shear stress in the coupling pin. The coupling pin is this one. If they say they are looking for the coupling pin. If the pin is to shear, where will this pin shear? The pin will shear here and here. So to get the shear stress, we know Shear stress is given by force divided by area, which we are going to write force divided by area. The force we already know, it's what? 100 times 10 to the power 3. What is the area? Looking from the top, if we were to remove this, the pin is round. So its diameter will be pi divided by, its area rather, will be pi divided by 4 times its diameter, which is 20, will be 0.02 squared. But remember, this pin, if it were to share, it will share in this position and in this position, meaning we are going to have two areas or 2 points that are going to separate. Therefore, we are going to say times 2 to the area that we are going to get here. And then that will give us the shear stress of the pin, which is going to be 159.155 megapascal. And that is our question number 2. And then we go to question number 3. Question number 3, they say the tensile stress in the fork of the coupling. So we are having a situation like this. We're having the fork. This is the top view of the fork. There is a pin here. There is a force that is applied to that direction. The force is 100 kilonewton. According to Newton's third law, it will be, we will take as if we are going to have another force here, because this thing is at equilibrium. It's not moving to the left nor to the right. So according to Newton's third law, there will be another force that is applied in that direction, the same magnitude, opposite direction. So now, the reason why I'm taking the force from here, not from here, is because the pin here, if I were to stretch this thing to that direction, the pin is resisting this thing to move in that direction, meaning the pin is applying the same force with in the opposite direction. So then this section of the fork will then experience tensile load or tensile stress. So if I were to say this is XX, draw a cross-sectional area cutting on line XX, cutting line XX, looking it from this direction, I will end up with something like this. This is the hole. Okay, it's not like this. This will be the hole. And these are the areas that we are going to work with. Area number 1, area number 2, area number 3, area number 4. And they are equal. Area number 1 is equals to area number 2 equals to area number 3 is equals to area number 4. Why are they equal? It's because the distance from here to here is the same. The distance from here to here is the same. And they also have the same thickness, which we are given as 15. So now, to calculate for the tensile stress in the fork, we know stress is given by force we already have, divided by area. Area, it's the one that we are going to use from this sketch. So we are going to calculate for area number 1 because they are all the same, and say times 4, because we are dealing with 1, 2, 3, 4 areas that are experiencing the tensile load that we are talking about. So now our next job is to get the area, the magnitude of the area. We have to get this distance from here to here. We are going to say the distance from this point. Let me change color so that you see what I'm doing. We are going to say the distance from this point to this point minus this distance, which is the circle, and then divide by 2. Because if we are minusing this, we are going to get this distance plus this distance. We're dividing by 2 so that we are only getting the distance from here to here, which will be the distance from here to here. And we know that thickness is 15. So how am I going to do that? I'm going to say 80, which is the distance from here to here, minus 20, which is the diameter of the hole, divided by 2, which will give me 30. 30, it's my distance from here to here, and then here it's what? 15. We're given 15, meaning our area, the area that we are dealing with, it's equals to 15. Okay, let's put it in millimeters. It's 0.03 times 0.015. Then we are now going to calculate the stress. Stress is given by force divided by area. What is this? The force? 100 times 10 to the power 3. 0.03 times 10, 0.015. All of that will be times 4. And then we are going to get our stress as 5.55 megapascal. And that is our last question, and that's it for this lesson. I will see you on the next one.